Yes, good morning to everyone. I am Nicola Sorrentino from University of Calabria, and I will chair the session regarding the project that is its acronym is Sensei. Briefly, I will recall that I will start my brief presentation regarding the project. Just I have to share my presentation. Just a few minutes, few seconds. Okay. Okay. Well, I welcome to the presenter that will introduce very briefly after this my brief presentation regarding this special session. First of all, we have just a few words regarding the project. As I say before, this is a special session regarding the concept and the first results of the project Smart Energy Services to improve the energy efficiency of the European building stock. This project was financed in the framework of H 2020 of the European Commission. The main ambition behind Sensei is to provide a transaction model based on a P4P scheme that will allow energy efficiency to be regarded as exploitable resource for the power system. To plan for pilots in the EU, where stakeholders that are willing to compensate energy efficiency and stakeholders that can bring potential projects, building owners and ESCO. So we are working in defining a model, a new business model, and we'll try to apply to some pilots in EU. This is the partner that the department that works in Sensei. There is a large partnership, and so this ambition we want to obtain in this hero project will use the very high expertise of each partner. The special session is articulated in 4 presentations. Then we have a question and answer section in which we try to have some feedback from the people attending to this special session. The first paper is towards a performance-based energy economy, the increasing value of pay for performance scheme. And it is presented by Sotiris Papadelis, that is the director of EBES Intelligence, holds an MSc in mechanical engineering from the National Technical University of Athens, and has 15 years of working experience in both consulting and research and development projects, funded by national and international sources in the areas of energy efficiency, transportation, and private-public partnership. Please, Sotiris, the floor is yours.
Perfect. Let me share presentation. I'm sure if I can see. It's quite brief. Hello, everybody. It's a quite brief presentation. It's about the concept of pay for performance and performance-based contracts in relation to how energy efficiency can be linked with the power system. I have just one slide for the project. It's already mentioned by Nicola. It's a 3-year project. We already have consumed one. We have 2 years remaining. This is the website. And if someone goes to the website, they actually find a lot of references for pay for performance. Pay for performance is mentioned a lot. And also this idea, this concept of using energy efficiency as a resource for the power system, the power grid. And the question is why? And this is related to the whole concept of Sensei, because I assume everyone that watches this presentation is familiar with the idea of demand response and why demand response is important, and the idea that as we move towards a 100% renewable energy system, we'll have supply sources that are not controllable, not exactly dispatchable, so we have variable generation, and one way to deal with it is flexible demand. Okay, demand that's able to follow the needs of the grid. And this is what we call demand response. But Sensei aimed to examine how energy efficiency could actually play a role also in a renewable-based electricity system, not replacing demand flexibility, but supplementing it, enhancing it. And a few definitions just to make sure that everybody's on the same page. When we say, at least in Sensei, when we say energy efficiency, we're talking about persistent and maintained changes in the energy consumption profile of the consumer. The key word is change. It's not necessarily reduction, in the sense that there are energy efficiency measures that could decrease consumption, at least during some hours of the day. For instance, when we're talking about fuel switching, when you replace an old oil-fueled boiler with a heat pump, something like that. And maybe you don't have so much a reduction in consumption, but a shift in the timing of it. For instance, tankless water heaters. You remove the tanks, or you remove a source of inefficiency, but now you may create a new peak of demand during the morning hours, for instance. So it's about a persistent and maintained change in the energy consumption compared to the baseline level. What was the consumption before the energy efficiency intervention? And this intervention can be from equipment upgrades, can be from installation control technologies, or envelope improvements. And all three aspects are important in Sensei. Then we have demand response, which is the active change, shift, reduction of consumption based on some signal, some command signal, some price signal from the grid. And then there's demand flexibility, which is the actual capability for demand response. Demand response is the result. Demand flexibility is the capability that may a building possess. So the important thing for Sensei is how energy efficiency and demand flexibility interact. And the idea of why we would like to focus on the interactions comes of the acknowledgement of the fact that generally, when we're talking about demand response, when we're talking about energy efficiency, we're talking about two things that are completely separated in terms of the markets, the schemes that support financially, etc. When we're talking about demand response, you always have this idea of TSO, system operator, making available specific products for consumers or prosumers to actually participate in the balancing market. You have an aggregator that actually acts as an intermediate so that the aggregator is responsible makes the contract with specific requirements and penalties and all that with the system operators, and then the aggregator is responsible for finding buildings that have flexibility potential to actually provide the services to the power system. And this is visible and dispatchable by the system operator. But when we're talking about energy efficiency, we're talking about something completely different. We're talking usually of some institution that has a budget and a mandate to support energy efficiency and provides some kind of support, usually through grants or no interest loans, and consumers use this support to improve their buildings, for instance. And because there are these two completely different worlds, usually there's no interaction in terms between them. Interaction in terms of, for instance, a unified planning or an idea of how one affects the other. But there are interactions. Okay, we know that there are interactions, and here you can see at least two major. One is that energy efficiency can affect capability, flexibility capability in terms of the load that's available for setting or shifting. You may have an efficiency measure that reduces the amount of load, or you may have a measure that shifts load from peak to off-peak periods, or the other way around. Or you may have a measure that actually can increase flexibility potential. For instance, envelope improvements can make a building more suitable for thermostatical loads, control of thermostatical loads in terms of demand response. And then we have the fact that energy efficiency by itself, or the measures that are implemented, may affect the power system's need for demand flexibility. There may be, because of energy efficiency, reduced demand during hours when you usually need capacity reserves, so now you need less. Or you may have cases where energy efficiency may be detrimental to demand response, in terms that there are cases where you would like increased load because you have periods of renewable energy curtailment. A lot of demand response signals are actually about increasing demand. So anytime an efficiency measure reduces load at this hour, actually increases the need for demand response. And the idea of sensing, or at least one of the ideas of sensing, is that if you want to unify energy efficiency, or at least to think in a coordinated way about energy efficiency and demand response, you have to unify the way you plan for them. We're not saying in sensing that demand response and energy efficiency are equivalent and can be part of the same market and the same operation schemes. There are different. Demand response is dispatchable, energy efficiency. But this unification, this unified view can be done and makes sense to do it at the planning level. And for that, one interesting idea that we build our results upon is this categorization that is done in California, where technically a lot of things are put under the umbrella of demand response. And some things are what you would expect when you hear the term demand response. For instance, ancillary services, the ability to react to the grid's requirements quite fast, from hours to seconds. But also you can move to larger time scales and think about load shifting and then load modifying. And this can actually be an incentive for energy efficiency and behavior change. And if you think about it, time of use rates are more about incentivizing your new investments in your building in terms of equipment, for instance, etc., so that to capitalize and benefit from the pricing schemes, rather than trying to chase the grid requirements. So time of use rates are more about incentivizing energy efficiency rather than providing ancillary services. So one can think of a large spectrum where both fast demand response and energy efficiency measures can be regarded as different classes of demand side resources. And if you do this, then the next step, and again, we base a lot of our ideas on the things that come from the US and California, is this idea of pay for load shape, which is actually what is an idea that you need a way to steer energy efficiency interventions towards measures that are beneficial for both the building owners and the grid. And you need some kind of incentive. And the idea again, it's not to put it in the capacity market or something like that, but to think in terms of the existing programs that financially support energy efficiency and see how you can include a component that actually differentiates the rates that are provided, differentiates the compensation and the support that is provided, having also an incentive for energy efficiency measures that can actually lead to load shapes, to consumption profile shapes that make the life of the power system operators easier. This idea of making life easier could be about offsetting the need for new generating plants or new transmission line upgrades. So it's about forward looking. It's about what you would need in 5 to 10 years from now. And if you need new capacity, then maybe some part of it could come from energy efficiency measures that you have already incentivized in order to achieve the optimal result in terms of lowering the long-term cost of power system operation. And this idea of paying for load shapes and paying for load shape changes is actually aligned with the pay for performance concept. The whole idea of pay for performance is that you pay for something, in our case for energy efficiency, based on its actual impact and the seasonal and time of day characteristics of the changes, instead of assumed results or deemed results. And if you think about it, both the idea of providing incentive for energy efficiency measures that are aligned with the needs of the power grid and pricing schemes like the time of use aim to do the same thing, huh? to provide benefits, more benefits to consumers for which it's cheaper to serve their loads. And this can be done through incentives or bill savings. So it's another way, instead of thinking in terms of pricing, in terms of pricing schemes, we think in terms of aligning existing energy efficiency support schemes that actually include this component of aligned with the power system requirements. And it's paving the way to its transition towards 100% renewables. And still, the idea of Sensei is actually, okay, this is theoretically fine. Let's try to set up some pilots. Some pilots where we test this idea and we use this idea as a purpose to see what would work best, or the best combinations of having payments, incentive payments, pricing schemes, demand response programs, all of them in an effort to reliably serve part of the expected future load through demand side resources. So what are the requirements towards such pilots? We have identified two major requirements. One is the need to assess avoided costs from target load shapes. We said before that the idea is that you pay according to the new generation plants the degree to which the need for new generation plants is mitigated. This has somehow to be calculated. And for this, we will actually need some change, some expansion to the usual way capacity adequacy and flexibility studies are carried, because the current practice for these assessments treats energy efficiency improvements as an external input that's part of the different scenarios for future demand. And in contrast, if we want to set up such pilots, we actually need methodologies and specific ways in which we analyze the ways different load changes at different scales. I mean here, scales in terms of megawatts of capacity, for instance, affect the need for these new generation plants, and also for the need for new generation plants that our analysis suggests that they are not economically viable. So you would need an additional financial support, and maybe you would need to introduce a capacity market for that. And the second requirement is, you say, pay for performance. So you have a way to measure this performance. So you need a way to estimate accurately and transparently the changes in consumption profiles based on this baseline that was aforementioned. And this is a problem for energy efficiency as much as a problem for demand response. Anytime you want to compensate demand response, you have to see what was the result from a signal, a price signal or a command signal, in terms of what the consumption would have been without it. And the main argument of the SENSEI project is that measurement and verification, and this is what is called now advanced measurement and verification, or MMV2, can lay the foundation for such pilots and programs, because it provides a way for automated and more or less in real-time estimation of energy efficiency improvements. The whole idea of MMV2 is using real-time data and some predictive modeling tools in order to have a continuous feedback on the actual impact from the energy efficiency intervention. And SENSEI, in that sense, is making the first step towards not only providing an MMV, a proposed MMV methodology that will actually be open source and fully replicable, but also the first step towards establishing the first scheme for certifying such methodologies in a hope of a better and wider adoption. Both of these challenges or requirements actually correspond to specific deliverables. In SENSEI, we have a deliverable 4.2 that's called the drivers of value of energy efficiency as an energy resource, and it will present a proposed methodology on how you can actually include active energy efficiency planning into the standard approach of capacity adequacy flexibility studies. Our goal is not to provide methodology and say that this is what we propose, is to start by proposing methodology and then hopefully collaborate with regulatory, I should say, authorities for energy, energy institutes, system operators, in order to use this methodology, fine-tune it, improve it, and make it adaptable to the different challenges of the different power systems found in the EU. And then we have a deliverable 7.1, methods for the dynamic measurement and verification of energy savings. We present SENSEI's contribution to advancing the state of the art in MMV, and provide methodologies and tools that actually are replicable by practitioners. So it's not just theory, it's theory and tools that can actually be used and tested in order to verify that they work, or at least to verify for which buildings, which type of buildings, and which type of consumption profiles they do work and can be trusted. And we have a stakeholder community that its whole purpose actually is to be able to collaborate with stakeholders and see which our tools and methodologies are actually useful and how they can become even more useful And this is the down at the bottom of the presentation, the link where anyone who wants can join our stakeholder community. And thank you for your attention.
Thank you, Satiris. Then we'll, if you remove the screen share, please. Okay. Just we can go to the second presentation. The title of the presentation is Pay for Performance Models to Foster Investment in Energy Efficiency in Buildings. Presenter is Charles Henry Burgess, that spent most of his recent years of his career as an independent consultant and a subcontractor in the fields of energy efficiency, renewables, and energy climate policies. He also has a solid experience in managing energy savings programs, ranging from the pre-audit to the implementation and the financing phase. Please, Charles, the floor is yours.
Do you see my screen?
No.
Okay.
Yes, you can. Now we can.
Right. It worked this morning, so one moment. Not yet?
No. We'll see your desktop.
Yes, okay. I'll stop sharing and reshare again. Now?
Yeah, it's okay.
Thank you. Okay, so good morning to everyone. My name is Charles Bourgois, as introduced by Nicola. I want to say a few words from the Sensei project, specifically from work package 6, which focuses on the link between the Sensei project, Pay for Performance, and the investors community, the energy efficiency investors community. How Pay for Performance might trigger more of investments in energy efficiency. I'll say a few words about energy efficiency as an investment, how it's functioning today. Then we did an exercise within the Sensei project to start quantifying financially the benefits of energy efficiency projects. And then I'll focus on what this represents as financial flows in a potential pay for performance scheme as introduced by Sotiris, and a few words on the next steps in the work package. First, energy efficiency as an investment. I always like to start with this slide when talking about investments in energy efficiency. It's from 2008, I think, but it's still very much valid today. When we compare energy efficiency to common other type of investments like treasury bills, long-term bonds, common stocks and small company high-risk stocks, we see that energy efficiency actually is a very good investment when looked at it from a financial point of view, with a low risk index, with a low year-to-year volatility, and a high average annual return. Now, the problem is that although we have this very interesting investment opportunity, and although we also have a very high untapped potential of energy efficiency investment projects, and we still consume too much energy. Estimates vary around 30% still easily and economically viably investment possibilities in energy efficiency. Why is it that we still have that high untapped potential? Why is it that investments in energy efficiency projects are still lagging behind? It's in the last International Energy Agency report on energy efficiency of 2020. The picture is quite grim. The investments in energy efficiency are down 9%, and the outlook for the next years are still not bright, so are even lower. And it's not due only to Corona. So for one reason or another, we have to find ways to boost energy efficiency investments. Now, in the framework of Work Package 6, we of course will look at how pay for performance might give that boost and foster energy efficiency investments. But of course, it's important to look at what has been done already until today, since the 70s, the 80s, in market development around energy efficiency services to boost the volume of financial investments in energy efficiency projects. And when we look at it, a lot has been done already. Of course, there has been the development of measurement and verification protocols, very important. And Sotiris talked about measurement and verification 2.0, which will, of course, be needed to develop P4P models to measure and verify load curves. But measurement and verification has been there for a while. The 1.0, if you want, based on total annual consumption volumes. Standards for professional, what they call investment grade energy audits have been developed to try to make the financial community more confident in believing the results of an audit. Very professional tools have been developed based on statistical data from all over the world of implemented energy efficiency projects, tools that help doing these energy audits and do the pre-engineering of energy efficiency projects, all to gain more confidence from, more trust from the finance community. Of course, energy performance contracting has been developed as a contract and a market mechanism to kind of securitize or to do risk management of energy efficiency projects. In the recent years, more attention has gone to secondary benefits or what we call the multiple benefits of energy efficiency. And I will come back to that to show you the importance of the financial value of these other benefits of energy efficiency projects on the next slide. There has been a lot of dialoguing and dialogue platforms created between the financial world and the energy efficiency world. Think about the Investors Confidence Project, de-risking energy efficiency project, energy efficiency finance community, working groups, thinking groups. All these are more or less, well, if you see 1.1 till 0.5 are all advancements that have been made, developments that have been made to foster energy efficiency investments at project level. But of course, also things have been done at what we would call program level, larger number of projects, the development of what we call energy efficiency structured funds, which is a kind of collaboration of financial people managing a large fund, but through a very qualitative energy efficiency project management process for admission and selection of ideal investment projects in energy efficiency. A lot of securitization mechanisms, financial vehicles have been designed specifically for energy efficiency project context. And of course, we have subsidy programs, energy efficiency obligation schemes, which I will come back a bit later to. But still, given all these instruments, we don't see the real boost that we are expecting and that we actually need to meet climate goal objectives at European level, at world level, since it is estimated that to reach these goals, 50% of the work to be done will be in energy efficiency. 50% will be in renewables, change of fuel, and 50% of the effort has to be made in energy efficiency. We're far from that, very far. So the work we are doing now is looking at this pay for performance model and see, can this bring, or at least an additional boost to what we are seeing as investment volumes in energy efficiency today. Now, I said I would come back to this multiple benefits. It's a point we looked in much detail at in work package 6 in Sensei. And I have an example here. It's from a very interesting source, looking at all the benefits that go with energy efficiency projects, other than or on top of the classical energy savings, energy cost savings. And just an example, if you look at point 1 here, we see an item, a benefit called work productivity increase. We've done a lot of research on that at Factor 4. We've developed a method to do an ex-ante calculation of work productivity increase and to measure it afterwards and to actually define performance parameters that we can put in a contractual framework for an ESCO and say, okay, we have this work productivity and we want that much productivity increase at the end of the project or at the end of a few years. And if you look at the values in the last column here, PV stands for present value or over the lifetime of a project. I think the project here is project over 25 years. We see a benefit valued at 220 around euro per square meter of a retrofit project in a building. Now, this work productivity increase is all due to comfort increase. Energy efficiency improvements go with comfort increase. If you look at what we usually look at, point 5a, the energy cost savings, the pure energy cost savings on the bill, we look at a figure of 350 euro per square meter. So actually we have two benefits. One you would think is very secondary, and I took the lower level. If you take the higher level, it's even bigger than the energy cost savings. So it shows clearly that secondary benefits of energy efficiency products have to be looked at and taken together with the energy cost savings in the whole financial business case of energy efficiency projects. And that's why this attention for multiple benefits has attracted more interest from finance people also, especially for the KPIs, the benefits that can be calculated, forecasted, and measured afterwards. Now, I talked about multiple benefits. It's an important word. It's more or less a buzzword in energy efficiency world. It's not only at project level, when with the red title here, that we have additional benefits on top of energy savings. We could look at a broader scope and look at the effects of energy efficiency projects on the grid, on the utility system, and also on reaching societal benefits. Reaching these goals and delivering these benefits to the utility system has a value. And that's where we come to the idea of pay for performance. We need one way or another to value these benefits and to try to get them to internalize them into the business case of energy efficiency projects. Although, when we look at these type of benefits, the benefits will go here typically to system operators, to energy providers, balancing companies. They will not be interested at a individual project level. It will not be interesting to develop a market around these benefits or a contractual framework around these benefits at a project level, but rather at an overall level, at the level of many projects, what we would call in the framework of Sensei and other P4P projects, an aggregated level. And this holds true also for the societal benefits.
Sorry, Charles, yes. You have 5 minutes.
Okay. Okay, so basically, when we look at the financial aspect of what I just told, these benefits at program level, we need kind of mechanism to harvest them. And when we look, for instance, at the utility benefits, and we look at the retrofit project, we see that we have a customer paying for a bill to the energy provider. We do a retrofit. We have a smaller energy bill that's still paid to the energy provider. We have energy savings for which investments had to be done. And these investments has to be paid back to the investors. But on top of that, what we assume in the P4P framework is that the energy provider will have benefits from this project too, and will pay for it. Of course, we have to look at how this goes, but there are examples in the United States, for instance, where this happens. So there is a rate for savings achieved that an energy provider or utility is ready to pay, which can make an additional revenue stream for the investor. So that's very important. I think in the framework here in Sensei, these additional benefits at program level, utility and societal, or additional revenue streams that come into play. On the societal benefits, we can look at this. Today, we have subsidy schemes, authorities, energy agencies, and with subsidies for energy efficiency investments to boost them, to stimulate investments and to reach climate goals. In a pay-for-performance scheme, there is no initial subsidy like in an energy efficiency obligation scheme, but a rate will be paid, a kind of a payment to the implemented energy efficiency project based on the results achieved by the project for a certain number of years. Also examples there a lot in the United States. Now, as I said, and this brings me to my 2 last slides, the utility benefits and the societal benefits will not work or will not develop in a market. We will not develop a market around those benefits if we look at single projects. This will only work if we can aggregate projects. And that is where the Sensei model comes into play, where we define a role. It's not defined in detail at this moment, but of a player that will aggregate a lot of projects, energy efficiency projects, from different program participants that work with ESCOs, and that will be aggregated, and this aggregator will deliver an aggregated sum of benefits to a system operator, an agency, or an energy supplier. From the viewpoint of the investor, and that's very important, that's what we are investigating now, this leaves many options for investment opportunities in energy efficiency, given the new revenue streams that are created. It could still be at individual level. It could be in agreements with the ESCO, like happening today. It could be with the aggregator. Examples of that also in the United States, bonds issued, funds created by the aggregator, or directly with the system operator. With the advantage that these players play at a higher level. This is an institutional player, which could give more guarantee to a third-party investor. So in conclusion, from what we have analyzed so far, we see that pay for performance is certainly a good way to capture additional revenue streams. I think that's really important. Additional revenue streams from a system operator, energy climate authorities, or maybe other societal organizations. It's only interesting for a system operator and an authority if many projects can be aggregated. Otherwise, the effort in administration, financial administration, will be out of proportion towards the revenue stream. And then what is really important, since we see it as an additional revenue on top of existing energy efficiency revenue mechanisms and contractual mechanisms, we will have to look at how they are correctly distributed between the individual project level and the program level, and between all stakeholders at these two levels. Like, for instance, a building owner would be at a project level, an aggregator would be at a program level. And so I conclude, that's what we are working on now at this moment, is define the potential arrangements between these stakeholders, taking these 3 points above on the slide into account, including project and program level. It's very important. We will engage with external stakeholders, as already mentioned by Sotiris, and we will dry run within the framework of Work Package 6, we will dry run some concepts on a building set. So that was it from my part.
Okay, thank you very much, Charles. Then, if you, okay. The next presentation is devising classes of energy efficiency measures to evaluating pay for performance rates that energy provider will be willing to offer in pay for performance scheme. The presenter is Arturo Lapietra, is a project manager at Dell'Energia in Cosenza, Italy. He has 10 years of experience in the ICT and energy efficiency sectors. He carries project management activities for Italian and H2020 R&D projects. He deals with the innovation and the digitalization of corporate process through an ERP for energy buildings. Please, Arturo, the floor is yours.
Thank you, Nicola. Good morning, everybody. Please share the screen.
Arturo, please try to have your presentation in 15 minutes, please, so to have enough time also. Okay.
So I will go very quickly. Good morning, everybody. So go so deeply in my work at this stage in order to reflect the 15 minutes Nicola suggests. As we know, buildings account for 40% of use final energy consumption. And then the energy efficiency in buildings has been identified by the European Commission as a very real major opportunity. But despite its potential, the current building renovation rate in EU is very low, in particular due to the lacking of private investments. For energy efficiency, as already Charles mentioned before, to be attractive to investors, it must be associated with consistent returns and stable long-term cash flows. In this challenging context, the Sensei project proposes a pay-for-performance business model in the EU, which offers an effective way to engage both energy providers and third-party investors in energy efficiency. Pay for performance scheme aim to deliver greater and more persistent energy savings by paying energy efficiency resources based on a comparison of metered energy consumption and modeled counterfactual energy consumption. Energy savings are used as the indicator for the energy efficiency project's performance. The payments are channeled from an organization which is willing to pay to support energy savings. The experience of P4P scheme outside EU suggests a public authority, a utility, or other entities to e-projects. So some P4P schemes outside the EU provide an upfront non-performance-based incentive in addition to performance-based payments. This approach helps participants to manage cash flows and financial risks. It is the case proposed in our study, which the energy providers become the entities willing to pay for the rollout of energy efficiency intervention and the P4P scheme. The transition of the electricity system towards complete decarbonization requires the full integration of energy efficiency measures with the acronym EM to reduce the carbon dioxide emission on a long-term basis while avoiding the need for costly capacity and network upgrades. This study provides a concrete classification and evaluation of the various EMs, which provides the foundation for proposing a definition of P4P rate that is transparent and non-performance-based incentive that can be offered to and for energy providers. We use the acronym EMs to refer to both measures that decrease energy consumption and the deployment of solutions for on-site generation of renewable-based solution for heating and cooling. 5 different ways in which an energy efficiency intervention can modify the load profile have been categorized. As you can see from the slide, we have measures that reduce the use of electricity without affecting its temporal profile, measure for improved control of electricity consumption, or that affect both the electricity used and the time of use. Measure that increase electricity consumption due to fuel substitution, or the installation of the technology for the generation of the electricity on site. So we defined different categories according to the principle which energy is saved. Then we have this category: distributed generation plants, storage systems, conversion from fuel to electric, building envelope, thermal plant, electrical systems, and BACS, building and automation control system. We structured different tables for evaluating the energy efficiency measure. The so-called table A provides an analysis of the quality of the intervention from the grid side. Table B analyzes various technical and economic aspects of the measures, considering the user's perspective too. Table C evaluates a large number of parameters in order to calculate with some uncertainty the energy saving by taking into account the financial and economic aspects of the energy efficiency measure. For each analysis, for each table, a class of goodness is resulted from each EM. From the higher value, 10 corresponds to the letter A, to the lower, 1 to J, as the table shows. At the end, Table X is a fusion of the analysis conducted in the three previous tables. The classes of EMs have been contextualized for different sectors: industrial, commercial, and residential. To date, most of the P4P programs outside the EU have been implemented in the commercial and industrial sectors. But we provided also a residential classification of DMs because with the deployment of smart meters, the procedure for collecting data becomes less complicated and the cost of wall building measurement and validation activity decrease and become more practical for P4P scheme. And the figure, the histograms, is shown an example of the class X results in the commercial sector. After devising the classes of EMs, the P4P rate concept is devised through the mechanism of energy efficiency obligation scheme and considering the TSO perspective too. In our vision, the energy provider could be a transmission system operator or a distribution system operator. First of all, we defined the P4P rates as funds transferred per energy saved. The basic idea behind the proposed approach is that the energy provider could set a higher value for P4P rates the greater is the class of the EMs we presented earlier. This energy provider could be willing to offer a P4P rate in the Sensei value chain basing on their proper needs and their development plan. The figures show the EOS mechanism. It's set a target usually in terms of energy savings that need to be achieved by energy companies as obligated parties under the Energy Efficiency Directive. The obligated energy companies can be distribution companies, suppliers, or retailers. They have the freedom to achieve the target set for them through a range of means. They can deliver the target through providing energy efficiency measure directly to customers, can work with intermediaries, or they can, in some circumstances, purchase energy savings through a trading mechanism, so-called white certificates. But in our study, we suppose that energy companies could deliver the energy savings target by providing energy efficiency measures directly to customers. The energy companies could so introduce P4P rates, incentivizing the Sensei model to implement energy efficiency intervention as an energy system resource. This would lead to larger savings at lower cost, achieving the energy savings target in a quickly and direct way. In order to evaluate P4P rates for complying with the EOS, distribution companies could use the classes of the pre-announced table C. Depending on the class achieved in table C, the P4P rates level will be indicated in accordance with the table at the right side of the screen. The energy company so could be willing to pay a maximum value for each ton of oil equivalent saved. As the TSO, European TSO incorporates in its strategic planning the aim of decarbonized economy through an energy transition based on the integration of renewable sources, energy efficiency, and storage system. At this end, the TSO may have an interest in financing EMs and could support the Sensei model with economic incentive, defining a maximum value to pay. In order to support the TSO development plan drivers, the decarbonization goals especially, The classification of the AIMs provided in the previous table X is the best fit for the P4P rate definition. So an energy provider could set a higher value for P4P rates the greater is the class of the AIMs. As explained before, the transition of the electricity systems toward complete decarbonization requires the full integration of EMs in order to reduce emission on a long-term basis, avoiding the need for costly capacity, lowering carbon emission, avoiding or deferring the need for costly network upgrades, and allowing heating and cooling system to be used more flexibly. Associating these benefits with consistent returns and stable long-term cash flows could result in making energy efficiency more attractive to energy providers and third-party investors. So I think to have 3 minutes left, Nicola.
Yes.
Okay. Some people, we are going to the conclusion. So some P4P schemes implemented outside the EU provide an upfront, non-performance-based incentive in addition to performance-based payments. This approach helps participants to manage cash flows and financial risks. Such a method is also proposed in this study, considering that energy providers or energy company are the identified entities paying for providing an upfront incentive through the rollout of energy efficiency measures. The proposed approach is not focused on quantifying the P4P rates, but on identifying which variables and parameters can affect these rates. To this end, one of the first proposals of this report was the definition of the classes of energy efficiency measure, and then evaluate the P4P rate accordingly. In particular, we supposed and we focused on the role of the energy provider in this, that energy provider could have in this new scheme. Therefore, since a project, through the role of the aggregator, could turn to the TSO to receive an incentive following the implementation of energy efficiency intervention, bringing overall benefits to the grid. Associating these technical benefits with consistent returns and stable long-term cash flows could result in making energy efficiency more attractive to investors. At the end, as Sotiris already explained, I will invite you to join our community. It is, of course, free to join, and you can always unsubscribe. Thank you to everybody.
Thank you very much, Arturo.
15 minutes.
It's okay. You are great. So if you leave it there.
Yeah.
Okay. Thank you very much. I then can share my screen just to introduce the last presenter. The paper is adaptability of pay for performance schemes for promoting energy efficiency in the EU. The presenter is Philippos Ananiostopoulos, that is a senior associate at AIEE and the scientific coordinator of the H2020 project Sensei. His expertise relies with the formulation, implementation, and evaluation of climate and energy policies, and more specifically with energy efficiency in the building sector. Philippos has published research on the topics of energy efficiency policy impacts, de-risking energy efficiency investment, building databases, certification schemes, energy service market activities, the role of public buildings, and requirements. Then the floor is yours, Philippos, and if you try to maintain 50 minutes, it will be great. So we have 10 minutes for questions from the floors.
Thank you, Nicola. Welcome, everyone. So let me share the slideshow. I suppose that you can see my screen now?
Yes.
Perfect. Hello, everyone. As Nicola introduced, I'm Philippos Anagnosopoulos. I coordinate the Sensei project, and today I want to speak to you about the adaptability of pay-for-performance schemes to promote energy efficiency. This will be a rather short presentation. It's based, well, first of all, because like a lot of things have already been said, so I will skip the introduction of what pay-for-performance is. But I would like here to focus more on how that really impacts policies and what are our recommendations, at least our preliminary recommendations. So yes, let's skip that. You've seen it in previous presentations. Maybe keep the model up. So I have some notes a bit. So with Sensei coming online and essentially pay-for-performance schemes coming online, we have these new technologies entering the market. And so the legislative framework also needs to adjust and to enable these associated business models to align. And the purpose, of course, is to help deliver on significant policy objectives, namely on the increase of energy efficiency, reduction of CO2 emissions, associated employment opportunities, economics, and so on. So our ongoing work aims to strengthen this viability of pay-for-performance business models in the European Union under different potential policy scenarios in the near future. So in order for us to achieve this, we aim to deliver certain strategies whose aim is to support the exploitation of upcoming opportunities, but also to adapt to potential unfavorable developments within the regulatory framework. So first, I will very briefly present to you our methodology, and then I will proceed with these preliminary findings and policy recommendations. So on our methodology, essentially, to develop these strategies, which is step 5, we start with the first step where we review the existing European policies, regulations, directives, and so on. Then we identify these more specific policy areas in step 2 that may hinder the integration of pay-for-performance schemes, but also the areas where we identify favorable conditions where pay-for-performance schemes can build on. The next step is to devise scenarios, develop different policy pathways, and see how those relate to pay-for-performance schemes. Then we do a SWOT analysis to identify strengths, weaknesses, and so on. And lastly, this leads us to identify which would be the most appropriate strategies, building on those strengths, weaknesses, opportunities, and risks. This is an ongoing work at the moment, and most of the work has come up to the third step. So, and I will prepare the aspects that are most developed. So in the first step, we have done this extensive desk research, and we have reviewed the legislative framework within the EU. And most of the material, of course, consists of policy and regulatory documents, but we have also looked in academic papers and grey literature. So we have basically included the existing policy environment, disaggregated by policy areas. We have seen the relevance of the Sensei business model to the EU regulations, as well as other initiatives, perhaps even of non-legislative nature. So let's proceed directly to some of the findings, and I know there's a lot of text, so please bear with me. So the biggest implication of pay for performance in EU legislation is on the Energy Efficiency Directive. This is a quick summary of how it fits into specific articles and also to some of its annexes. So the main impact is with Article 7, where we have the energy efficiency obligation schemes. We have seen, like this is the experience from the United States, that where energy efficiency obligation schemes are active, they have been the driver for the development of pay for performance schemes. I mean, if there's one thing you get out of this presentation, this is it. Pay for performance schemes so far seem to click very well with the obligation schemes, and this seems to be so far at least, the best way forward for their adoption. Important as well are the methodological requirements for the accounting of savings. And this goes mostly for P4P schemes that are managers that will need to consider how these guidelines are developing and how the baseline consumption methodologies are being set. So this is also on the level of guidelines. Another one, which is mostly important for public authorities making use of pay for performance schemes, is Article 5 for the obligation of central government buildings, the 3% annual renovation rate. So here, and I read, the measurement systems promoted in the context of pay for performance schemes could help assess the impact of renovation and behavioral measures, especially when combined. And also, very, very importantly, Article 8 on energy audits. Here we see that pay for performance schemes can actually be the energy audit itself in a way, but they can also very much follow up audit recommendations by monitoring the operation of the building. Continuing with the Energy Efficiency Directive, we have Article 18 on energy services and Articles 9 to 11, which are more on the metering and billing. So Article 18 is quite important because P4P schemes can facilitate the emergence of energy service markets and also allow them to expand into new segments. And here I mentioned the residential sector. The thing is that quite a lot of these programs have mostly focused on big buildings and mostly in the commercial sector. And the experience we have from the US shows that also residential buildings, small properties can be aggregated to be included in the schemes. Lastly, for the Energy Efficiency Directive at least, the articles that relate to metering and billing are extremely important for pay for performance schemes. They need to be updated, and we also have a number of policy recommendations for EU institutions as they will be reviewing these directives in the context of the European Green Deal. So these articles are very important because, of course, the pay for performance schemes use meter data to calculate the achieved savings and, of course, then disperse the respective payments. Another aspect where there will be some impact in EU legislation, or at least practice, is on energy performance certificates. And we see those, of course, in the Energy Performance of Buildings Directive, the EPBD, but also related to the European Data Strategy. They are important on the left side. because EPCs and its performance certificates are a key opportunity for the development of pay-for-performance schemes, as building owners accept business models that will provide them with increased benefits derived from energy retrofit projects. And also, when we speak of data, this is increasingly important because accessing this data is key in order to have pay-for-performance schemes. These presentations will be available, so you can have a read at your own pace. I'm quite rushing through them, admittedly. The other places where pay-for-performance schemes can be important, albeit in a secondary manner, is the Energy Taxation Directive, the Electricity Market Directive, and also, even not expected, the Emissions Trading Scheme. And essentially, the main function here is through their ability to promote energy efficiency. So in the context of the Energy Taxation Directive, energy efficiency can enhance and align the rollout of pay-for-performance schemes. In the Electricity Market Directive, pay-for-performance schemes raise the ability of energy efficiency to play its role as an energy system resource, which is extremely important, and it's also one of the targets of Sensei. And also within the ETS, in the case that large industrial installations opt to work with pay-for-performance schemes, then the EU ETS could facilitate the rollout of these schemes when we're talking about energy efficiency measures. And that leads us to a few recommendations, some early recommendations, actually, I should say, for the EED and EPBD based on what we have just discussed. So the first one, and I read, is to require obliged parties under the energy efficiency obligation schemes to devote some of their targets, to meet some of the targets, using innovative approaches. And here, of course, this would mean pay-for-performance schemes. Not limited to, but innovative approaches points to that. Also, it's important to promote the use of metered energy savings methodology. And this is essentially the annex of the Energy Efficiency Directive. And having these new technologies, the annex could now be updated. And a very important element is also to incentivize the installation of smart meters, primarily when buildings undergo renovation or major renovation. We'll see that, of course, smart meters are not necessary, but their widespread rollout will allow a better application of these methodologies for pay-for-performance. Then we have, of course, a recommendation of the introduction of pay-for-performance for public support schemes in order to ensure cost-optimal allocation of public resources, and that is mostly related to Article 7 again. Also to promote the synergies between minimum energy performance standards, again for Article 7. These are the energy efficient application schemes. And quite importantly, as we saw earlier, we have the ability to link energy performance certificates, not with an estimated consumption, but with the actual consumption and performance of building. And this, of course, is something that relates to a number of ongoing similar initiatives, such as building passports or updatable EPCs. A last recommendation, mainly on data, is, and that's something we'd like to stress, is the necessity to provide third parties with access to anonymized aggregated customer data. And in order to do that, we need regulations and technologies that enable this data-rich environment. Also, interface standards to exchange data. And here we also foresee, for example, the role of SEN and SENELEC. And lastly, which is very important for the protection of customers, the ability to have strong security protocols. And with that, I wish to thank you for your attention, and also mention that this is some ongoing work, and more of this will be coming out soon. Thank you all very much.
Thank you very much, Philippos, for your presentation. Well, if there are some questions from the floor, you can use demand and response section or in the chat session in order to make some question to the presenters. We have a few minutes because we have to stop at 10:30, as this is mandatory for organization point of view and for the platform. So we may have one or two questions, please. There is a question for La Pietra. Then you can write the question. In the chat. Arturo, you have seen why is the value of P4P expressed in euro kilowatt hour rather than euro per kilowatt?
As I explained earlier, the performance in a P4P could be generally evaluated in terms of energy. For this reason, we used this first idea, euro per kilowatt hour saved. I think that the two concepts could be strictly related, but the focus of our work was not to identify precisely the calculation of the P4P rates, but I said before, to identify the variables. And our general approach could be accordingly adapted in a calculation which the result could be an euro per kilowatt hour or euro per kilowatt.
Any question? Or some of the presenter can add some consideration on this question?
Nicola, can I add?
Yeah.
I think actually I agree with Arturo, and actually both can be useful in metrics when deploying pay for performance. It's not only the kilowatt hour saved, although that is the initial thought or the initial scope of the Sensei project is looking at energy efficiency and see if it can be valued as a resource on a broader level than only for the building owners and the ESCOs. So these other benefits have other metrics. So the euros or the rates can be both per kilowatt hour or per kilowatt, and even derived units, I think, as I explained with the multiple benefits.
There are more questions from the attenders. Well, we don't have any question from the attenders. So if you have any question, further question that can be done offline, we may use as the contact that will be present in the website. You can contact the presenter by email that are present in the conference list participants, and the final our final invitation is to join, as we several says, to the stakeholder section of the Sensei project in order to have more and profitable. We have another, sorry, if you have just in time, there is another question. Do you have any example of incentives for EE improvements for households? This is an open question. It's not directly to a presenter, a specific presenter.
I think every country has, more or less. In Greece, we have this program that is it's called Exconomo, which can be translated as I conserve, and it's a yearly basis. It's about households. This year it has become I conserve and automize. So it's the first year where they actually focus so much on also solar PVs and batteries. But they provide no interest loans for energy efficiency improvements for residential buildings.
Okay, then we have to stop. I thank again all the presenters. I will thank the attenders, and I will thank the organizer that allows to host this special session regarding the Sensei project. So we'll see the next session at the AIEE Symposium. Okay. Thank you very much again to everybody. Have a good time. Bye.
Bye-bye.
Bye-bye.